All right, hello everyone. Welcome to DV Systems webinar series. This webinar will be on how to size and select an air compressor for the automotive market. Choosing an air compressor can certainly be a challenge, especially if you don't have all the necessary information or are unfamiliar with the questions that you even need to ask. Air compressors are used in a wide range of applications and power a wide range of tools and equipment, and the size and type of air compressor used will depend on the particular needs of the application. But the questions to ask to arrive at the right choice of air compressor are generally the same. DV Systems manufactures air compressors serving many segments of the compressed air market, ranging in size from 5 horsepower air compressors used in small shops to large 200 horsepower air compressors used in industrial applications. Today, we will focus on the automotive service industry, specifically auto repair and auto body shops and facilities, and provide you with some simple, useful advice and tools to help you make the right decision in sizing and selecting a suitable air compressor for your particular needs. Vehicle service, repair, and auto body shops typically rely on 5 to 30 horsepower air compressors with 80 to 240 gallon air receivers that power an automotive shop's pneumatic tools and equipment. Piston, otherwise known as reciprocating air compressors, are also still the most common type of air compressor in the automotive services industry, although this is quickly changing due to the increased benefits and reduced costs of rotary screw air compressor technology. Let's look at our agenda. In part 1, we are going to cover 3 basic but essential questions you need to ask in order to help you properly size an air compressor. And then in part 2, we'll cover 3 additional questions you need to ask in order to properly select an appropriate type of air compressor for your particular application, whether it be a piston or rotary screw air compressor. We will highlight the most common mistakes that are made in sizing and selecting an air compressor and provide a few useful techniques that will help guide you in making the right choice. Let's look at the 3 questions you need to ask in order to properly size an air compressor. How much compressed air do you need? What pressure do you need? What kind of electrical power do you have available on site? In part 2, we will look at 3 additional yet important questions you need to ask to help determine what type of air compressor is suitable for your particular application. What do you use the compressed air for? How quiet do you need your air compressor? And how clean do you need your compressed air? So let's start with how to properly size an air compressor. The first essential question to ask is how much compressed air is needed to service the demands of your auto repair or auto body shop. What volume of compressed air delivery is needed to keep everyone working smoothly without interruption? This isn't an exact science, since activity in a shop is always changing. What we're trying to achieve at this point is a good estimate, allowing for some fluctuations in demand up and down. What you need to know is compressed air delivery is measured in SCFM, or standard cubic feet per minute. SCFM is a standardized measure of the volumetric flow of compressed air. Every pneumatic tool and piece of equipment has an SCFM requirement, and every air compressor has a maximum SCFM output. In order to correctly calculate the actual air requirements or the rate of flow for anticipated compressed air end uses, it's necessary to identify every pneumatic tool and equipment in your auto repair or auto body shop and add up their SCFM requirements. All of your compressed air tools and equipment should specify their compressed air consumption under load in SCFM. If these numbers aren't listed on the tools and equipment themselves, they can typically be found in the manufacturer's product manual or on their website. Let's highlight a common mistake here. Just because a pneumatic tool specifies that it uses, for example, 40 SCFM of compressed air doesn't necessarily mean that it uses 40 SCFM all of the time. Most of the compressed air tools and equipment in a shop are not in use all of the time, all day long. This is where the concept of use factor comes into play. The amount of time a pneumatic tool or equipment is actually used versus the time that it is not. There are pneumatic tools that are used some of the time, intermittently, and there are pneumatic tools that are used for longer periods of time or continuously. Again, this exercise isn't an exact science and there isn't one perfect answer, but a useful technique that simplifies the process of determining your compressed air requirements for a given application is to identify all of the uses of compressed air and then group them into either intermittent use or continuous use. For example, it's safe to assume that one mechanic uses only one tool at a time and generally does not pull the trigger all day long. A half-inch impact wrench for changing tires would probably be used intermittently and used for only some of the time during the day. This tool would be grouped as intermittent use. Other than general mechanic work, there are some activities that are particularly heavy users of compressed air, such as sandblasting, grinding, and other auto body shop activities such as spray painting. These activities use pneumatic tools that consume a lot more compressed air and are also used for longer periods of time or continuously. These types of tools would be grouped in the continuous use category. Let's look at some examples to help us begin to understand how to estimate a shop's compressed air demand, as well as illustrate the differences between intermittent use and continuous use. After this brief exercise, we will also provide a general rule of thumb that will help you estimate an average auto repair shop's compressed air demand if you are lacking detailed information. Our first example is a general auto repair shop with 2 bays as well as 3 technicians. Let's assume that there are 2 auto lifts, a tire changer, and a buffer, as well as 2 impact guns that could be used simultaneously. All of these compressed air tools are typically used only some of the time during the day and relatively short periods of time. They can be categorized as intermittent use. Using some intuition, we'll estimate an average use factor of 15%. You can think of this as either the tools are being used 15% of the time during the day, or for 10 minutes of every hour, or for 10 seconds out of every minute. Adding all these tools and equipment together, taking into consideration their use factor or the proportion of time the tool is on versus off, result in an average compressed air demand of approximately 15 SCFM. So the half-inch impact wrench that we first mentioned when talking about use factor, which consumes 40 SCFM at its peak use, actually consumes only 6 SCFM based on a 15% use factor. A rule of thumb may also be used to provide a rough estimate of the compressed air requirements if these details aren't available. In a typical auto repair shop, each technician usually uses around 5 SCFM. So if there are 2 bays with 3 technicians working at the same time, a rough estimate of the total compressed air consumption would be around 15 SCFM. Let's look at another example. A typical collision repair facility may have the following pneumatic tools and equipment: a spray paint booth, an HVLP spray paint gun, a prep station with a sander and grinder, as well as a paint mixing room. The sander, grinder, and spray paint gun are generally used for extended periods of time and consume a considerable amount of compressed air. They are categorized as continuous use. Adding all these tools and equipment together, taking into consideration their use factor, results in an average compressed air demand of approximately 51 SCFM or 99 SCFM if the air compressor is supplying compressed air for the blowers in the spray paint booth. Now that we've estimated how much compressed air is needed, we need to know what pressure is needed. Pressure is measured in PSI or pounds per square inch. Working pressure is the pressure to which your air system is set. Working pressure is determined by the specifications of the compressed air equipment and tools used. Different types of equipment and tools typically demand different operating pressures. Normally, the tool or equipment with the highest operating pressure determines the needed working pressure for the entire system, and other equipment and tools are fitted with pressure-reducing valves or regulators at the point of use. So take a look at the specs for the various compressed air tools and equipment you have, and whichever has the highest operating pressure basically sets the pressure required for the entire system. We also have to account for pressure losses, or pressure drops that occur in the system. Pressure drop is a reduction in air pressure from the air compressor discharge to the actual point of use. It represents the energy lost as the air travels from the compressor to the point of use. Each additional component in a compressed air system, such as air piping, air dryers, and air filters, contribute to pressure drop. Pressure drop could range from 5 psi for a good large diameter aluminum air pipe system to 20 to 30 psi, or even worse for a poor small diameter iron air pipe system. So for example, if the highest operating pressure of all the tools in your shop is 90 psi and you are using an existing air pipe system with an average pressure drop rating, then your minimum system pressure might be 110 to 120 psi. Let's highlight another common and unfortunately costly mistake. Contrary to popular practice, you don't really want to run your compressed air lines at a higher pressure than what is really needed. Compressing air takes a considerable amount of energy, and the higher the pressure, the more energy is used, the more heat the air compressor generates, and the more wear and tear the air compressor bears. So it's important to keep your working pressure as low as possible. Here's another helpful hint. Make sure you have a good air pipe system that can reduce pressure losses and take a lot of the unnecessary work off of your air compressor. What's a good air pipe system? One that has a large diameter air pipe. The larger the diameter of air pipe, the better. How the air pipe system is designed is equally important. A full loop system around the shop versus a single line that dead ends makes a big difference, giving you potentially twice the air capacity. Invest in good quality quick connects that have a large opening and good large diameter air hoses. This is where a little extra money spent will make a huge difference. High quality quick connect aluminum air pipe systems are available from DV Systems. You can learn more on our website dvcompressors.com. Now let's look at the third and final question to help us properly size an air compressor. What kind of electrical power do you have available on site? An air compressor is typically the biggest energy consumer in your shop and usually contributes the most to your electricity bill. The size of air compressor that you can get is often limited by the type and amount of electrical power that you have available on site. The first thing you need to do is determine whether you have three-phase power or single-phase power available to you, what the maximum electrical service available to you is in terms of amps, and also what voltage is available on site. All of this information should be verified by a certified electrician. You don't want to make a mistake here. A lack of accuracy could be very costly. This highlights another common mistake. It's extremely important that the air compressor matches the electrical service that is available on site. Let's illustrate the importance of this with an example. If you only have single-phase power available on site, you will typically be limited to a 5 to 7.5 horsepower air compressor, or in the case of our revolutionary Huron V10 rotary screw air compressor, a 10 horsepower air compressor. To give you an understanding of the electrical power that is required, a standard air compressor will draw a current approximately 7 times its full load amps on startup. This means that when the air compressor first starts up, it requires 7 times the electrical current it takes to run normally. For example, a 5 horsepower air compressor on single phase will need more than 100 amps of current available when it starts up, and a 7.5 horsepower air compressor needs more than 200 amps of electrical current to start up. This is the primary reason why it's important to ensure the maximum electrical service on site is enough to supply the air compressor's current draw on startup. In the case of the Huron V10 rotary screw air system, however, its variable speed direct drive starts the motor gradually with an extremely low maximum 55 amp draw, eliminating current spikes on startup, allowing installation of a 10 horsepower air compressor in locations where it was previously uneconomical or even impossible to install. So now we've covered the 3 critical questions that give us an understanding of what size of air compressor is required. How much air do you need? What pressure is required? What electrical is available? This gives us a good understanding of the approximate compressed air delivery required in SCFM, the size of the air compressor in horsepower, the required system pressure in PSI, and the necessary electrical service needed to meet these demands for your application. Now that we know the approximate size of air compressor required, how do we select an appropriate type of air compressor? How do we decide between a reciprocating air compressor and a rotary screw air compressor? Once again, this isn't an exact science and the answer isn't black and white, but a few helpful questions will point us in the right direction. What do you use your compressed air for? How quiet do you need your air compressor? And how clean do you need your air? Answering these questions will give us a good idea about whether a rotary screw or reciprocating air compressor is appropriate for your particular application's needs. Let's begin with our first question. What do you use your compressed air for? Or how do you use your compressed air in a typical day? We saw that understanding how you use your compressed air, either intermittently, continuously, or both, is necessary in approximating how much compressed air delivery you need in your shop. How you use your compressed air throughout the day will also help determine what type of air compressor is best suited for your particular application. Just like compressed air tools and their activities have use factors, the proportion of time a tool is used versus the time it isn't, air compressors have duty cycles, the proportion of time the air compressor can operate without the risk of overheating and sustaining excessive wear versus the time the air compressor needs to stop and cool down before it resumes again. This highlights another important point to remember. Selecting an air compressor with a duty cycle rating appropriate for your compressed air usage is critical. Different types of air compressors have different duty cycles. Rotary screw air compressors have a 100% duty cycle and can run continuously 24/7, while pressure lubricated heavy-duty industrial piston air compressors have approximately an 80% maximum duty cycle, needing to cycle off 20% of the time, and splash lubricated industrial air compressors have approximately a 60% average duty cycle, needing to cycle off 40% of the time. Keep in mind these ratings refer to an 8-hour day. Let's see what this means in terms of sizing and selecting an appropriate type of air compressor using our previous example of the auto repair shop with 2 bays and 3 technicians. The compressed air demand was estimated to be 15 SCFM. For illustrative purposes, let's assume that 15 SCFM is the absolute maximum compressed air demand ever needed by this repair shop. It's an unlikely circumstance in real life, but suitable for our purposes of explanation. We're going to show you a simple calculation that will let you know how to size air compressors with different duty cycles to a given compressed air demand need, in this case 15 SCFM. In terms of rotary screw air compressors, which have a 100% maximum duty cycle, we will divide 15 SCFM by the number 1.0, which represents 100% duty cycle in decimal format. This results in 15 SCFM, meaning we need a rotary screw air compressor that can deliver at least this amount of compressed air at a maximum 100% duty cycle. The Apache A5 rotary screw air compressor delivers 16 SCFM of compressed air and would meet the 15 SCFM demand while running at a 94% duty cycle. Alternatively, a B5 rotary screw air compressor, which delivers 18 SCFM of compressed air, would meet the demand while running at an 83% duty cycle. How do we know that the Apache can service the demand while running at a 94% duty cycle and a B5 can service this demand while running at an 83% duty cycle? Simply divide the compressed air demand of 15 SCFM by the Apache or B5's maximum SCFM output, in this case 16 and 18 respectively. So 15 divided by 16 equals 0.93 or 93%, and 15 divided by 18 equals 0.83 or 83%. In terms of pressure lubricated heavy-duty industrial series reciprocating air compressors with a maximum duty cycle of 80%, we divide the 15 SCFM compressed air requirement by 0.80, which represents 80% in decimal form. This results in 18.75 SCFM, meaning we would need a heavy-duty industrial air compressor that generates at least 18.75 SCFM. Our 5-horsepower heavy-duty industrial series delivers 19.1 SCFM at a maximum 80% duty cycle. In terms of splash lubricated industrial series reciprocating air compressors with an average maximum 60% duty cycle, we divide the 15 SCFM compressed air requirement by 0.60, which represents 60% in decimal form. This results in approximately 25 SCFM, meaning we would need a splash lubricated industrial air compressor that generates at least 25 SCFM. Our 10 HP industrial series delivers 31 SCFM. In very general terms, if your compressed air uses are intermittent like the previous 3-bay 2-technician auto repair shop example, you can most likely use either a reciprocating or rotary screw air compressor. But as you can see, the sizes of these air compressors will vary in terms of horsepower depending on whether you choose a rotary screw, heavy-duty industrial, or industrial line. If your compressed air uses are primarily continuous use, like the auto body shop example, a rotary screw air compressor is most likely recommended, rather than oversizing piston air compressors to meet the demand. How you answer the remaining questions will ultimately help you decide between a reciprocating or rotary screw air compressor. Let's continue on with the second question you need to ask to help determine what type of air compressor is suitable for your auto repair or auto body shop. What noise level is acceptable if noise is an issue? Do you need a relatively quieter air compressor to allow your technicians to work in peace as well as work safely? Let's compare the differences between a reciprocating and rotary screw air compressor. Rotary screw air compressors are considerably quieter than reciprocating air compressors. DV Systems rotary screw air compressors are enclosed in a powder-coated, heavy-gauge acoustically insulated steel cabinet with a sound attenuating foam barrier. And there aren't any pistons banging away loudly while air is being compressed. Rotary screw air compressor technology compresses air without any mechanical contact between the rotors and the air end, causing it to be considerably quieter with less wear. To give you an understanding of these relative noise levels, a normal conversation at 3 feet registers at 70 dBA. You can stand by a rotary screw air compressor and easily have a normal conversation with someone. In fact, you'll be louder than our Apache A5 rotary screw air compressor, which is ideal for noise-sensitive applications with a sound level rating of 65 dBA. Also, from a safety perspective, prolonged exposure to excessive noise levels impacts a worker's physical health and mental well-being. This is why reciprocating air compressors are often segregated from the main shop floor in an enclosed room or even a separate building. If noise is a concern and a separate isolated space isn't available or too costly to construct, a rotary screw air compressor is the most appropriate and convenient choice. The final question to ask is, how clean do you need your compressed air? For some applications, such as auto body spray painting and refinishing, there is no choice. You absolutely need clean, cool, dry compressed air. The end product is directly affected by the quality of compressed air provided, and the cost of refinishing is far too high to risk being contaminated with dirt, oil, or water. For this type of work, you absolutely need to include good quality compressed air filters and an air dryer with your air compressor. DV Systems DF Series compressed air filters remove oil and other contaminants found in air, and DV Systems Pro Dry refrigerated air dryers remove moisture to provide clean, cool, dry air for sensitive applications where compressed air quality is essential, such as auto body shops. Generally speaking, the compressed air filters and air dryer are sized to match the air compressor, but many of our rotary screw air compressors are available in complete air system packages, ready to plug and play, making it an easy solution. For other activities, such as general auto repair shop compressed air tools, you have a choice. You can run the equipment on dirty, wet air and deal with the wear and tear of the tools and equipment, or you can invest in compressed air filters and an air dryer and greatly improve the performance and life of your compressed air tools and equipment. In the previous auto body shop example with a demand of 51 SCFM, the compressed air is predominantly used for continuous use activities such as sandblasting, grinding, and spray painting, which certainly demands clean, cool, dry compressed air. Using the simple duty cycle calculation introduced in our first question on air compressor selection, we see that the C-Series C15 air system, which delivers 57 SCFM of compressed air at 100% duty cycle, would adequately meet the demand requirements at an 89% duty cycle. Not only does the C-Series C15 air system meet the demand requirements reliably and efficiently, but it also meets the compressed air quality requirements by providing clean, cool, dry compressed air. So let's review the questions that need to be asked in order to properly size and select an air compressor for your auto repair or auto body shop. In order to size an air compressor, ask the following questions. How much compressed air do you need in terms of SCFM? What pressure do you need in terms of PSI? What kind of electrical power do you have available on site in terms of phase, volts, and amps? In order to help you select an appropriate air compressor, ask the following questions. What do you use your compressed air for? Do you use it intermittently, continuously, or both? How quiet do you need your air compressor? And how clean do you need your compressed air? Before we move on to the Q&A session, remember that we have provided a very general overview of the process of how to size and select an air compressor. This simplified take is meant to give you an introductory understanding of the process of choosing an air compressor. In order to adequately size and select an air compressor for your auto repair or auto body shop application, it is recommended that you get in touch with an official DV Systems Sales and Service Center for a comprehensive assessment. And that concludes our webinar on how to size and select an air compressor for the automotive market. Now we will continue on with our Q&A session. Just bear with us a moment while